This problem that we're going to work on next is a little bit complicated. So let's kind of, we're going to have to break this down into small pieces. It's a kind of a classic work problem. So two people could finish a job, either of them individually, in some amount of time, or they can work together. And the question is, well, how long will it take them to finish this if they're working together? So we have, it's lawn mowing. I've got two characters in this story. I've got Royce and I've got Marcash. And Royce could finish mowing this lawn in 50 minutes. Marcash could finish mowing that same lawn in 40 minutes because he's a little faster. So if they both work together, how long will it take them to mow the lawn? Well, I have here, right here is Royce's timeline for finishing the lawn. 1, 2, 3, 4, 50 minutes. So each mark is 10 minutes. Okay? And after 50 minutes, he'll mow the whole entire lawn. So after 10 minutes, he is 1, 2, 3, 4, fifth of the way done. 1/5. So after 10 minutes, he's 1/5 of the way done. Right? So 10 is 1/5 of 50 minutes. And so in that amount of time, he has mowed 1/5 of the lawn. Okay? So let's go over and take a look here. I'm getting ahead of myself. We set up a table. I have time. All right? So I'm going to put down in 10 minutes, Royce has finished 1/5 of the lawn. Well, Marcash, on the other hand, here's a picture of his timeline. He can mow a little bit faster. So in 40 minutes, he's completely done. So in 10 minutes, he has done 1/4 of the amount of time it takes him to finish the whole lawn. So he has mowed 1/4 of the whole lawn. So Marcash would have mowed 1/4 of the whole lawn. If you look down here, kind of a picture. Here is Royce and Marcash. Okay, so Marcash in 10 minutes would mow one column, and then in the next 10 minutes he'd mow the next column, then the next 10 minutes he'd mow the next column, and then he'd mow the last column in the final 10 minutes, and he'd be done in 40 minutes. Royce, on the other hand, would be mowing rows, one row in 10 minutes, 20 minutes is 2 rows, 30 minutes is 3 rows, 40 minutes is 4 rows, 50 minutes is all 5 rows. So every 10 minutes he mows 1 row, or 1/5 of the total. So if you look here together, if I were to like shade in this, I'd just a row for Royce. I'd be shading in this square twice, so I'll have to shade up just a little bit here. So together, Marcash mows 5 boxes, and Royce mows 4, for a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's add a total column, 9/20. Of course, I could get that with my calculator too. I could say that if Royce mows 1 ABC 5 plus Marcash mows 1 ABC 4, I get 9/20. So 9/20 for my total. Okay. All right. Well, that's not the whole lawn, right? That's, in fact, not even half the lawn. So let's see what's happened. Let's give them another 10 minutes. So now we have 20 minutes. Okay. So Royce, in 20 minutes, well, that's 2/5 of his entire amount of time that it takes him to mow the lawn. So that would be, for Royce, he would be mowing 2/5 of the whole entire lawn. Marcash, in 20 minutes, that's half the amount of time it takes him to mow the whole lawn, so he'll mow half the lawn. So down here, Marcash mows half the lawn. And let's take a look here. Our little diagram down here. So every 10 minutes, Marcash mows 1, 2, 3, 4, 5 boxes. So I'm going to shade in another 5 boxes for Marcash. So there's 4 and 5. And then Royce would do another 4 boxes. So let's see, 1, 2, 3, 4 all together. So that's going to be, well, if we count them all up, 18 out of 20, 18 twentieths of the total lawn. 18 twentieths, which is, let's see, that's the same as 9 tenths. Let's just check here. 2 ABC5, that's Royce's part, plus 1/2, 1 ABC2 gives us 9 tenths. Okay. Now I think we can see what's going to happen. If they go for another 10 minutes, they're going to be more than finished. But let's just check and see what happens. So let's see here. Let's give them 30 minutes. All right. And let's go over here and take a look at Royce's timeline. In 30 minutes, that is 3/5 of the entire time it takes him to mow the lawn. And so that will be 3/5 of the whole lawn. Well, and then for Marcash, 30 minutes is 3/4 of the time that it takes him to mow the lawn. And so that would be 3/4 of the entire lawn. And if we add these together, 3 ABC4 plus 3/5, we get 1 7/20, so we're over. It's 27 twentieths altogether. 27 twentieths, which is over the whole lawn. That's too much. So we've gone too far. So sometime in between 20 and 30 minutes. So we could look at some times that are sort of in between. And let's look at how we would look at in between times. Let's go back to our timeline here. If we want to pick some sort of in between time, I could say 25 minutes for each of them. 25 minutes. If we look, it takes 50 minutes for Royce to mow the entire lawn. So 25 out of 50, well, first of all, I can see that that's 1/2. But let's write it as a fraction over 50. That would be 25 out of 50. And for Marcash, that's 25 minutes out of 40, or 25 over 40. And so in that 25 minutes, Royce would mow 25 50ths, and Marcash would mow 25 40ths. So let's do that. So that's 25 minutes. 25 minutes. And that's 25 50ths for Royce, and 25 40ths for Marcash. And so 25 ABC 50 plus 25 ABC 40 is 1 1/8, which is 9/8. So that's still too much. It's over half the lawn. But we could pick some other number. We could pick, say, 24 minutes. Right? Well, if we look at our timelines again, pick a number like 24 minutes. So 24 minutes, well, Royce would have mowed 24 out of 50 minutes, or 24 50ths. And Marcash would have mowed 24 minutes out of 40, or 24 40ths. Okay? Which means that Royce would have mowed 24 50ths of the lawn, and Marcash would have mowed 24 40ths of the lawn. So let's see here. At 24 minutes, we have 24 50ths. And over here we have 24 40ths. Let's add those up. 24 ABC 50 plus 24 ABC 40 gives us 1 and 2/25. No, we're still too much. 27 over 25. 27 over 25. So we're still over an entire lawn, so it needs to come down. Now the bad news is that if we keep coming down like this, we're probably going to miss our number. In fact, I'm pretty sure that we will. So let's take a look and see if we can't set up an equation that'll represent this relationship that we have here between how much lawn they mow and how much time they spend. If we can find an equation that relates those two, we can probably solve that equation and figure out what our time is. So let's take a look again here. You'll notice that however many minutes that they spend mowing the lawn, whether it's 10 or 20 or 30 or 25 or 24, whatever number of minutes they have, for Royce, it's always that number of minutes over 50, because he mows that number of minutes out of 50. Okay, so whatever he mows out of 50, and that'll be his portion of the lawn. Now over here, for Marcash, whatever number of minutes, we call it M, that he mows, whether it's 10 or 20 or 30 or 25 or 24, it's always out of 40, because that's his total time for the lawn. So M out of 40. If you look, you'll see here, we have 25 out of 50 and 25 out of 40, 24 out of 50, 24 out of 40. Even these 3/5 is really 30 out of 50 and 30 out of 40. So if we just had M minutes, then we would have M out of 50 and M out of 40. And then what are we doing with those two? Well, we're adding them together. So in our total column, I have M out of 50 plus M out of 40. So, and then in the end, what number are we shooting for? Well, we're shooting for them mowing the entire lawn. So, equals 1. One whole lawn. So however many minutes we have, divided by 50 will tell us what Royce's part is. This is Royce's part. And here, Marcash's part. Okay. So whatever the number of minutes is, it's minutes out of 40. That's Marcash's portion of the lawn. And minutes out of 50 gives us Royce's portion of the lawn. If we add those together, we should get 1. So now we just have to solve this equation. And we've actually solved a few equations like this already. But let's take a look here. I'm going to, I think we can solve this in this little piece of paper over here. M over 50 plus M over 40 equals 1. Well, I need to have a common denominator here. My goal whenever I'm solving an equation is to get the variable all by itself. Well, right now, I've got the variable over 50 and over 40, and I've got two different instances of this variable. I need to bring them together, which means I need to add these fractions together. I can't do that unless I have a common denominator. And I think a good pick for common denominator would be 200. So let's see. That means I have to multiply by 4. So 4 times M over 4 times 50. So that's going to give us 200 down here. And 5 times M over 5 times 40. And that's going to give me 200 over here. So let's see, that's 4M, this should be a plus, over 200 plus 5M over 200 equals 1. So now I can add the fractions together. 4M plus 5M over 200 equals 1. And now I can combine these 4M and 5M. I can make them 9M. 9M over 200 equals 1. We're getting closer. Now, I need to get rid of this 200. Well, I could do that by multiplying by 200. That'll cancel those out, so I have to do the same over here, which gives me 9m equals 200. And now, to get rid of the 9, I have to divide by 9 so that those cancel. So I have to divide by 9 over here, and I get m equals 200 over 9. 200 over 9. What's that? 200 ABC 9. That's 22 2/9 minutes. So m equals 22 2/9. So you can see how the guess and check would have been a problem here. I don't think I would have ever guessed 22 2/9. But let's go back and see how that works in our table. Okay, so 22 2/9 minutes. Got to remember that. 22 and 2. Oh, let's go with 200/9. So it'll be easier to work with. 200/9 minutes. Let's go back. So if m is 200 over 9, then this is going to be m over 50 is going to be 200 over 9 over 50. And over here we'd have 200 over 9 over 40. We have to add these together. So this is we have to use a little bit of fraction magic here. 200 over 9 divided by 50 is the same as, find a new place to work on this. I'm running out of space here. Oop. There we go. I'm back. Where are we now? Okay. 200 over 9 over 50 is the same as 200 over 9 times 1 over 50. And 200 over 9 over 40 is 200 over 9 times 1 over 40. So that is 200 over 450 plus 200 over 360. And let's see, I could reduce these fractions. Right, so that's going to be 20 over 45, 20 over 36. Just go ahead and use the calculator to add them. So 20 ABC 45 plus 20 ABC 36 gives us 1. So if Marcash mows 200 360ths of the lawn, and Royce mows 200 450ths of the lawn, then altogether they will have mowed 1 entire lawn. So let's go back, take a look at what we've done, just to review. First, we notice that in 10 minutes, Royce has mowed 1/5 of the lawn. And in 20 minutes, it's 2/5. 30 minutes, it's 3/5. And so on. And over here for Marcash is very similar. Since it takes Marcash 40 minutes to mow the lawn, in 10 minutes he's mowed 1/4, 20 1/2, and 30 3/4. But in each case, really, we can break it down a little further and say that it's 10 over 50 because it's 10 minutes out of 50. So it's 10 out of 50 for the entire amount of lawn he's mowed. 10/50ths of the time gives us 10/50ths of the lawn, but we would write that as 1/5. But if I have, for example, 25/50ths or 24/50ths, it's that portion of the time, which means he's mowed that portion of the lawn. Same for Marcash, say 25/40ths or 24/40ths. If he's mowed that for that portion of the time, then he has mowed that portion of the lawn. So the portion of the time is m out of 50 for Royce and m out of 40 for Marcash for just some random number of minutes m. Which means that after m minutes, if Royce has mowed M out of 50 as a portion of the time, he's mowed M out of 50 as a portion of the lawn. And for Royce, it's going to be M out of 40 as a portion of the lawn. So I just have to add these together and shoot for 1, which is what I did over here. We set up an equation saying that, that M out of 50 plus M out of 40 equals 1. We had to find a common denominator, add the two fractions together, and then we had to use our equation solving magic to get to 209ths as our answer, which is 22 2/9 minutes. And then we just went back, we kind of double checked by plugging that into our table, and we ended up with, yes, in 22 2/9 minutes, Marcash and Royce will finish the lawn.